In this video I'm going to show you how to use UID changeable cards with Arduino and the PN532. In my previous videos I explained how to use Arduino and the MFRC522, whereas here we're going to see how to use that in P7532. If you have seen my last video, which was on using ACR122U, it is exactly the same in PN532 also, because ACR122U internally uses PN532 as its reader writer chip. So in order to achieve this, you have to modify the libraries. It doesn't matter which library you're using. I have got a very comprehensive coverage of various libraries in my build your PN532 reader writer series of videos, and whatever we do in this video should work for all three types of connections. Either it can be SPI, I2C or UART connections. I'm going to show here using the SPI connections. So what you'll end up doing is, first thing is to write some of the missing functions in the library. So you don't have to always do this because it depends on the which library you are using. For example, we need to write functions for write registers and in communication through commands. Some libraries already have the write register functions and some may be having in communication through, so you have to check the library and you have to write the missing functions. We are going to use exactly the same sequence of commands we used in ACR122U, that's the Mobius instructions, and later in the video we're also going to understand what these commands are. So let me first get into the commands we are going to use. We have covered this in the last videos. So this is the commands we referred in the last video. To just above here we have been sending all these commands in the same sequence, and we have seen that these commands work in case of ACR122U, and also briefly mentioned about one more comments made by this user explaining what these various commands are. So I'm going to explain that in a little bit because it's very difficult to find more information about these commands. So I have opened the Arduino IDE and also using the library which is available in the GitHub, and I've explained this library in my previous videos. I'm using the SPI connection, so this bit is set to 1. What I did is, in this library there is an example to print the UID. So if you look at this, there is a example called ISO143 UID. I took this as an example and I saved this as a file called block0. So in Arduino it's not called as a file, it is called as a sketchbook. So I've just modified, I've written a function. So everything is just whatever it was before. What I did was wrote a function called write to block0. Inside this function I have just typed all the sequence of commands we have used in ACR122U. So first I'm going to run this and see it works, then I'm going to spend some time explaining a little bit about these commands. So you can see I've got a red the tiny or the PN532 mini board connected to Arduino, and I'm using SPI connections. So I'm going to upload So it's already uploaded. I'm just going to show here, and I'm going to compile it and upload. So I'm going to take a UID which we have been using in the previous videos. So this is the serial monitor, and I'm going to place it here and see. So you can see that the output has started to change. So I'm going to just come back to that soon now. So this is written. I'm going to take it out. Probably now I'm going to scroll it as well. So these commands start from, say, right from here. So the write registers, and after that sending the halt command, again something to the write registers, and finally sending this all the magic and backdoor commands. And this is the most important thing, where the entire the block 0 is written. So we can see that the block 0 has been written, because after this command we can see the UID of the card matches what was written in the block 0. So let's go back to the editor and see what that I have done. So this is the command we saw in the blog, and we have used this command. This command has got this command is called the write register command. So depending on the library you're using, the write register may be available, or you might have to write that. I'm using this library, and which already has got the function to write the register. So if you just scroll up, the best thing is to search the write register. So we need a command to write the registers. So this library has a command to write to the register. So write register takes the address of the memory and the value of the memory. So there is a command here to execute the PN532 command. So we'll not worry about how these things are they're done here, but we need this function called write register. So if you go back to this library function, you can see that there are only three sets of commands are used. One is the write register. We also need a command for in communication through, and we need a command for iData exchange. Most library come with the iData exchange, because this is the command used for a normal MIFARE read and write commands are done using in data exchange command. So you just have to look for the write register and in communication through register. So here I have written the in communication through register. If you go scroll down, so I have written I've added a function, and so here what I have did is I've enabled the debugging, so you can get more information about what's happening. So in this library there's a file called debug.h, and probably this you have to enable. You will find something like this. So just have to remove the comment and make this the debug symbol available. And I've written this function called in communication through, taking the command and length of the command. So it just you just have to go through and see how the other commands are written, and you can just get an idea about how to write this function. So let's not worry about just this command. This function is used to pass or used to execute the in communication through command of PN532. So this is the command. So I'm going to go through this command in brief, because it's not easy to find information. You look around, look at various blocks, and I got some information here. The first command that is sent, and keep in mind all these commands are sent after the tag is activated. The very first command is to activate the tag, and this command, this is in APDU format, and we're interested right from the D4. So D4, not D4 actually, D4 is also present always, starting from here. So we know that 08 is the command for write to register, and these are the addresses. This the first 2 bytes are address, the value, the address, and the value. So here this command, the write register command, I can pass multiple addresses and the value, whereas the function we have in the library can accept only one address and a value. So I need to use or call this function twice. So first for writing to address 6302, value 0, and call next address is 6303, the value 0. So I got some information from internet. So this command 6302 is called is to control the transmission data rate, the framing during the transmission. So basically what the value 0 means, disable the CRC. So somehow all these things are happening by disabling this CRC code and setting the baud rate to 10. This is a standard baud rate for the classic MeFair type A attacks, and this setting what type of framing we need is 1443A. So this is the command. So what basically, to summarize, what this does is disable the CRC and set the frequency or baud rate and the card type for the transmission side. And what I've done here is just I've given a delay after executing this command, and I got some nice message here as well, so I know whether command is breaking here or is continuing. And the next part here, the 6303 means defining the transmission rate and framing for receiving. So here the value 0 means disable the CRC and set frames and the baud rate. And once this is done, probably all these the disabling CRC is done because so that you can directly communicate with the card. This command from this instructions, it's a halt command, and 50, if you see any classic documentation, the 5000 is the halt command. Because we have disabled the CRC here, we have to manually send the CRC. Okay, so usually if you see usually now the CRC is computed by PN532 because we have disabled. This somebody must have the Mobius must have computed the value of this CRC for these commands, and this will never change. Or this is valid only for this command. So this is to bring the card to the halt. So far what we have got is the CRC is disabled and the card is in the halt state. So after that we have got one more write command. This command has got only one address and the value. So the documentation says it's adjusting the bit frame rate. So 07 means only 7 bits of the last byte is transmitted. Okay, so we have seen this kind of writing 7 bits in case MFRC 522, but I'm not very sure why it is done, but it works eventually. So after that, the next command is to send this backdoor command 40, and probably in order to send 40 you have to set this the 7 bit in the last byte. In order to send this command, we need the in communication through. So the in communication through command means the PN532 sends the whatever you pass in the command is sent directly to the card. So we are calling that in communication through by passing the 40, and after that there's one more write register, and this is write register, writing it to address 6330 and the documentation says this is again something to do with the transmitted value. 00 means we want to transmit transmit all the 8 bits. So this is something related to transmitting only the 7 bytes here. So here looks like this command um, brings this PN532 back to the default state where all the 8 bits of the last byte is transferred. After that, we are passing one more backdoor command called 43, and here we need to use in communication through command, and after that there's one more write register command. So here we are writing it to one single address, the value 80. So the value 80 means to enable the CRC. So here, so somewhere in the top we disabled the CRC. Looks like this command is going to bring back the normal working mode of PN532. So enable CRC, set it to 106 baud rate, and set the tag type to 1443A. And after that we are, so this is for the sorry, this command has got two addresses. So one, first to write it to 6302, the value 80, and second to write it to this. So we know that this is for transmission side, this for reception side. So on the reception side also we are setting it, enabling the CRC and other things. And the last command, this is a normal operation command which is in PN532 to write to a block. So we are using writing to block 0, and this is part of the library. Any PN532 library will have a command to write to MIFARE Classic. I'm just building this 16 bytes. This is taken directly from my software. So this also includes a CRC. The CRC is here, this is the type of the tag. And once this is successful, so that's the last command. If you see this message, that means the write to block 0 is done. And you can bring all these commands into one single function, and you can just call it anytime you like.